All right, calculus, welcome to your section 2.7, day 2, notes videos. This is for Thursday the 21st. All right, so this is from yesterday. We have the slope of the curve to the tangent line at a certain point, i.e. its rate of change at that point, its derivative at that point, is equal to the limit as x approaches a of f of x minus f of a all over x minus a. Yes, we will have to have that memorized. You won't have a quiz for a little bit on this. So that's something we can get down in the next 3 weeks. So the slope is always the change of y over change of x, and that's exactly what you have because y equals f of x. And that's literally when you plug a in for x, that's the y value you get. It's just that I'm trying to get as close as possible to that x value. That's why this is going to be 0, all right? I'm trying to get so very close to that exact point. When I zoom in big time, that curve will almost look like a straight line, all right? So the slope of the tangent line, the derivative. So on 1 through 4, it's the same direction. Find the equation of the tangent line to the curve at the given point. So f of x is equal to 2x plus 1 over x plus 2. That's f of x. And the point is 1, 1, so that's a, that's f of a. This is the slope is equal to the limit as x approaches 1 of f of x minus f of a all over x minus a. Again, this is 1 over 1. You need to combine these two, now fractions, in the numerator. So I multiplied this by x plus 2 over x plus 2. This is what I have now. When I combine them, I have 2x minus x. That's x, sorry. We were attempting a video before and then got a call I had to pick up, so that interrupted it. 1 minus 2 is a negative 1. All right, so it's x minus 1. And here, this is the true denominator. I just put it over 1. They're both in, this is the numerator of the true numerator, and this is the numerator of the true denominator, and they're both in the same spot, so they cancel. That leaves me with the limit as x approaches 1 of 1 over x plus 2, which equals a third, and that's the slope. So y minus the y value is equal to the slope times x minus the x value. Again, pause that. We did 6 of these yesterday. We're going to do 4 of them today, so we're going to have 10. We're going to have 10 total, and that's a lot. That's a lot of good examples there. So let's go to example 2. Example 2, f of x is equal to 8 over 4 minus 3x, and you have the point 2 comma negative 4. So the slope is equal to the limit as x approaches what? X approaches 2 of f of x minus f of a. Always subtracting the y value that you get when you plug that in for x. All over x minus 2. I'm really adding 4. Again, I want this numerator, those two terms, to be combined. So I'm adding 2 fractions. So I need to multiply these seconds. Now fraction by 4 minus 3x over 4 minus 3x. And over here, this is what it's looking like. 8 plus 16 is 24 minus 12x. All right, now this isn't like an x minus 1 over x minus 1 situation like I had previously. So I got to look at this 24 minus 12x. Can that factor? Yes, I can take a 12 out, divide both terms by 12, and look at this. So again, these two are in the same location, the 2 minus x and the x minus 2. And if you let x be 2, that's the 0 over 0. That's causing the issue. So they cancel, and they cancel to be negative 1 because they're opposites. So that's why here is a negative 12, and then the denominator, it's 4 minus 3x. I plug 2 in for x, and the slope is 6. Y plus 4 is equal to 6 times x minus 2. All right, that is your equation of the tangent line. So let's look at number 3. F of x is equal to 7 minus 2x squared at the point negative 1, negative 9. So again, there was, sorry I mentioned this in the previous video that was cut short, there was one homework question that I told you to wait on. You can now do that homework question. It looks very, very similar to one I maybe just covered. Hint, hint, wink, wink. All right, this is another good one I like to ask. 3 and 4 are great. These are great ones for either your homework or future quizzes. F of x is equal to 7 minus 2x squared. We got the upside down parabola at the point -1, -9. So the slope is equal to x, or the limit as x approaches -1 of 7x minus 2x squared minus a -9 minus f of a, the y value, all over x minus a -1. To subtract -1 is to add 1. Okay, so here's what I'm left with. Now this is something that's squared, that's quadratic, so I should think about factoring. I'm going to first factor out the -1, divide everything in the numerator by -1, put the -1 on the outside. Okay, let's be smart again. You know that the x plus 1's the causing the issue there, right? So x plus 1's got to be a factor up above, all right? If we're not great with factoring, you know x plus 1's a factor. So then 2x times x gives you 2x squared. 1 times a -9 gives you a -9. You can check it. -9x plus 2x is a -7x. It's been factored. All right, so what's going to happen? The x plus 1's cancel, and that's fantastic. Now I can plug -1 in for x. And slope's 11. So y minus the y value, so now plus 9 is equal to 11 times x minus a -1, which is x plus 1. That's the third one. Okay, I have the limit as x approaches -1 of f of x minus f of a all over x minus a. The -9's canceled. Okay, so then I'm left with this right here. I don't know. How is that going to factor? Goodness. So I need to do synthetic division. You could take an x away from everything and have 3x to the third minus 2x squared plus 5, but it's not 3x squared. So let's do synthetic division. Again, we're going to set what we're dividing by, x plus 1 equal to 0. -1 is x plus 1 a factor. Is -1 a solution? That's going to be a yes. I put a 3 for 3x to the fourth, a -2 for -2x to the third, a 0 for 0x squared, a 5 for 5x, and a 0 for the constant. There's 2 zeros here. Again, you did this in college algebra. Bring down the 3 because you're doing 3x to the fourth divided by 1x. 3 divided by 1 is 3. -1 times 3 is -3. Add the columns. -1 times -5 is 5. Add the columns. -1 times 5 is a -5. Add them up. -1 times 0 is 0. Add them up. Again, a book might show like long division, which is fine. But synthetic division, if you're dividing by, if that x is linear, it's not x squared or anything, then you can do synthetic division really easily. So what does this mean? Again, you did 3x to the fourth divided by x, so this has got to be 3x to the third. You always drop a power. 3x to the third minus 5x squared plus 5x. And you've divided. By showing synthetic division, you have shown how that x plus 1 gets factored out, gets divided out. So you've shown that. That's what synthetic division shows there. All right, plug -1 in for x. My slope's -13, and there is my equation in point slope form. All right, that is great. And I think that is enough examples of purely find the equation of the tangent line to the point. Those are nice, those are great. But we want to get to where this is really moving, and where this is really moving is the following definition. Here it is, folks. The derivative of a function f at a number a. There's a lot of a's in there, so I underlined the important a. The derivative, Yogi, you've been warned, buddy. Nope, you're good yesterday. I don't want to have to lock you up, buddy. The derivative of a function f at a number a. See, I can only stay on the first floor. I cannot get away from the doors where the squirrels can be seen, or the Amazon truck drivers can be seen. I am relegated to this first floor only. No upstairs, no downstairs. So where's Yogi gonna be? Right by me, by a door. probably making noise. So the derivative of a function f at a number a, denoted by f prime, this little apostrophe, we call it f prime of a, is this. So f prime of a, which is the derivative of f at a. F prime of a stands for the derivative. You're going to see, well, you'll see it tomorrow. Or the next day. You see it in section 2.8, f prime of x. Is the limit as h approaches 0. H is a horizontal distance, and that's what it was really doing in the last example. X minus a, that's a horizontal gap, and that was 0 because x was approaching a. Is the limit of f of a plus h minus f of a over h. Folks, this is very similar to the difference quotient. The difference quotient was f of x plus h minus f of x over h. You just didn't have the limit part. Okay, so instead of having x, we have a, and now we have the limit as h approaches 0, if this limit exists. So find the derivative of the function f of x is equal to x squared minus 8x plus 9 at a number a. So this could be at any number, because what we were doing before was great, but we were only looking at one specific point. I want to know the general derivative. All right, I want to know the general rate of change of a curve over its entire path. That seems like it'd be really important for like engineering, things in space, where we want to know where something's going to be at all times. We can figure that out. All right, so f prime of a is the limit of f of a plus h minus f of a over h, the limit as h goes to 0, that is. So the limit as h goes to 0 of, so I'm plugging a plus h in for x, minus, plug a plus h in for x. Don't forget about the plus 9. This is the whole f of a plus h part. Then minus, this is f of a, it's simply f of x, but with an a instead of x, all divided by h. All right, so I have then done the algebra, and you had a lot of practice with this, with the difference quotient. There, the algebra has been done. This is now f of a plus h minus, now the minus sign goes through. Be very careful. F of a or f of x later on needs to be put in parentheses, or else we're going to make sign errors. All right, we're going to make sign errors. So what cancels? A lot of things are going to be canceling. You know this from the difference quotient. The a squareds cancel. The a's cancel. The constants cancel. We're going to have things, terms that are left that have h's. Now I can divide everything by h. Now I can plug 0 in for h. And what you have there is a general derivative at any x value, a. You have the general derivative. Do you want to know what the rate of change of this is when x is 4, when x is 5, when x is a negative 10? Just plug those numbers in for a. This is a big deal. All right? Excellent. Now this is the limit definition of it, and chapter 3 will make it a little much quicker for us. But still, we have to understand the limit definition. We want this horizontal distance to be as close to 0. We're really zeroing in. We're really looking at a tangent line there. All right, let's continue. We got 2 more, and that will be good for today. Find f prime of a if f of x is equal to 3x squared minus 4x plus 1. All right, so yes, you're going to have to know this definition, but we're going to make it more formal. We're going to have an x in there instead. And if I ask you for f prime of a, you'll just know that an a is there instead. So yes, there's going to be 2. This is one of them. And I'll give you the formal limit definition of a derivative early next week. All right. So f prime of a is equal to the limit as h goes to 0 of 3 times I'm plugging a plus h in for x squared minus 4 times a plus h plus 1. Again, I'm subtracting all of f of a, so be careful. And I'm just doing the algebra there. All right. Pause this if you need to. Again, do try this. Do try this. Now, things are going to cancel. I already just canceled them here. That's, and that's, and that's, and that's. Bye-bye. As I distributed the 3 to those 3 terms. The a squareds will cancel. divide everything by h. Now you can see everything here. And when I let h go to 0, I'm left with 6a minus 4. Again, you are finding a general derivative for this function when x equals any number a. This is a big deal. All right, please check. Well, I mean, again, you'll learn the quick way, and that is derivative, so that is good. There's a way to check it quick if this is your, Yogi, we've heard enough. If this is your 6th time through, Calc 1, my tips for your teacher. All right, last one for today. Yogi, I'm rooting for you, buddy. Hate for you to do hard time again today. F of x is equal to x to the 3rd minus 4x. Again, f prime of a is equal to the limit as h goes to 0 of f of a plus h minus f of a over h. Again, think of it as slope formula. Difference of your y's over, I know there's no, that's because the difference of the x is 0, and h is going to go to 0. X minus a, if x is a, that distance is 0, that horizontal distance. Again, think of what's x. X is the horizontal axis. Is a horizontal distance. Difference of your y's over difference of your x's. It's just that your horizontal distance difference is going to be 0. So I'm going to plug the a plus h in for, I'm not going to make anything worse than a cubic. You know, we're going to save that till we know the derivative rules. Okay, that's a little unfair. Minus 4 times when I'm plugging in for x minus f of a. Now off to the side, I've done the work for a plus h to the 3rd. That's like a plus h squared times a plus h. This is a plus h squared, a squared. Then you're going to have 3 of the a squared h's. Then you're going to have 3 of the ah squareds. Then you're going to have h cubed. All right. So that is what we got. This is a plus h to the 3rd minus 4 times a plus h minus f of a. What cancels? The a cubes cancel. The 4 a's cancel. Is that it? I believe so. Here's what you're left with. Everything has an h. Divide now everything by h. Let h go to 0, and you're left with 3a squared minus 4. That is a fun one, and that is the last one for today. You can now definitely finish all homework set 2, which you scan that to me. It's gonna be nice. There's a way to use your Chromebook. Somebody did that in stats and sent it in one Google Doc, and I could read it well. But we have to make it look nice, and it has to be able to be, it's got to be readable. It's got to look nice. You guys are great with technology. If someone that, you know, spent a lot of high school with dial-up internet can figure this out, how to do it, you guys can as well. This is your domain here. Make it look nice. When you send it to me, if you send it to me early and there's no attachment, I'll let you know, but I'm not looking through your whole homework set. So you got to make sure when you send it to me, first off, go directly to your sent email and check to make sure, there's a PDF and that you can read it and all the questions are there. I'm just going to look to see if there's a PDF. I'm not going to click and make sure that you have all 18 questions done. All right, so make sure all the pages are there. All right, you guys can do this. This is really good prep for college when you'll have to do this, all right, in some classes. So please make it nice. That is due, Sunday by whatever I put in the email. Sunday, 9 p.m. Yeah, don't stay up to midnight. Don't do that. Send it in Friday. You can do it. All right, this is Yak Math Videos signing out.